Bismillah ar-Rahman ar-Rahim. Hello everyone. First of all, I'd like to thank the organizer of this conference for giving me the opportunity to be with you here. So let me introduce myself briefly. I am Benia Elias from Mila. I got my engineer degree from the National Polytechnic School of Constantine, and currently I am a PhD student at Farhat Abbas University. My research area is about modeling and control microgrids. As you can see on the screen, our topic today is hierarchical control of parallel voltage source inverters in Icelandic single-phase microgrid. Here we have the outline of this presentation. I've divided it into 5 main parts. The first point concerns renewable energies and distributed generators. Then I'll move on to microgrid concept. Next, I will focus on hierarchical control for microgrids. After that, we pass to the simulation results. And finally, we finish by a conclusion. Here, just to give a number about renewable energy sources. According to IRENA, last year, 2019, more than two-thirds of all new electricity capacity installed was renewable. And this confirms the trend of the world toward the renewable energy sources, of course motivating by the reduced costs. Here I give you a different way to show the continuous increase of electricity generation using renewable energy sources in the market since 2000. As we can see, basically hydropower is the most used one, then wind turbine and solar energy. Same way, we can see here the state of electricity generation using renewable energy sources in Algeria, which represents 0.013% of the world renewable energy generation, of course using renewable resources, and 1.42% of the electricity consumption in Algeria. To give an idea about the amount of energy that is incident in Algeria, it is good to make a comparison in order to have a reference, of course. As we know, Algeria produces 1 million barrel oil equivalent per day. However, the amount of the energy falling from the sky in Algeria is about 8 billion, which means 8,000 times more than we extract from the earth. It's really a huge amount, need to be exploited. Here we have the Algeria electricity consumption on the left side, which is about 56 billion kilowatt hour per year. And in the right side, the incident solar energy equal to 43 billion kilowatt hour per minute, which means 1.3 of solar 1.3 minutes of solar energy equal for a 1 year consumption of electricity. To be more realistic, we consider the PV panel efficiency about 20%. This implies 6.5 minutes. Of course, we can't cover all the surface by PV panels. As an approximation, 1 hour of solar energy equal to a year of consumption. It is really important to exploit this energy. How to facilitate the integration of renewable energy sources and to achieve a decentralized energy production and decarbonization. A new concept has been emerged. This concept called microgrid. A microgrid is conceptually considered as a small-scale grid formed by the interconnection of loads and distributed energy sources, such as we can see in this figure, such as microturbines, wind turbines, fuel cells, and PV panels, integrated with advanced storage devices, such as batteries and power capacitors. All of this on low voltage distribution system. Noticing that the microgrid have the ability to operate both in grid connected mode, so a microgrid tied to the main grid, or in isolated mode. Also, it can be in AC voltage or in DC voltage. Here, to control microgrid, many approaches have been suggested in the literature, but the most adopted one is the hierarchical control. As we can see here, the hierarchical control is divided into 3 layers. The first one is the primary control, which is responsible of power sharing and voltage and frequency regulation. Then the secondary layer, which allows the voltage and frequency restoration due to the deviation caused by the primary control related to the inherent characteristic of droop control. And the last one is the tertiary control, to manage the power flow between the microgrid and the utility grid. The advantage here is the customer can be part of the grid. Also, smart meters can be integrated in the up layers. Also, the secondary control can be divided into 3 classes: centralized, distributed, and decentralized control. In the centralized approach for secondary control, the microgrid is managed and optimized by a central supervisor controller called microgrid central controller. In the distributed approach, this approach proposes a communication between microgrid units, where these units can take decisions cooperatively by interacting to each other. And finally, the decentralized manner using a local controller, so there is no need for communication infrastructure. Here we have 2 types of secondary control was adopted in simulation. The first one is the centralized control up to secondary control, as we can see in this image, a parallel inverters feeding a load. And these are the blocks of primary control and centralized secondary control in the yellow color. Next, this is the diagram uses the decentralized secondary control, as we can see. So the compensation of deviation is installed locally. This is the simulation results. These figures show the operation of the voltage source inverter unit and illustrating the shape of current and voltage in output in the left side, as well as the active and reactive power in the right side, clarifying the stable operation of the system, which achieve a satisfactory signal performance for the voltage response and reaching its nominal values. These figures show the restoration of frequency and voltage using the secondary control. Initially, the microgrid was operating in the steady state under no load. The voltage and frequency were at their set points, and after that, we connected the load at 0.5 seconds. The drop of voltage was about 1.86 volt and 0.05 Hz for frequency. As shown in this figure, the centralized secondary control was able to eliminate the voltage and frequency deviation in 0.15 seconds, while the decentralized one is about 10 times of the centralized one. And this figure shows the parallel operation of the 2 voltage source inverters units and the centralized secondary control, where the secondary voltage source inverter is triggered at 0.5 seconds to analyze the dynamic of the system. As appears, the active and the reactive power were shared equally with high accuracy and fast dynamic, and with high agreement between signals due to the primary and secondary control. Finally, the statue of the power generation using renewable energies in the world and in Algeria is presented. The microgrid concept is explained, and the hierarchical control of a single-phase microgrid operating in Iceland mode is implemented. The hierarchical control is tested until the secondary control, of course, for both centralized and decentralized manner. And the objective of developing an Icelandic microgrid is achieved. Finally, thank you for paying attention.